several microbes are also responsible for the uh, for conducting the carbon cycle. And if you see, so these are the list of microbes. A huge list of microbes are there for the microbes responsible for the carbon cycle, and there are several type of microorganisms which are takes parts in the decomposition process. Uh, in each carbon cycle, carbohydrate act as an energy source for the microorganisms. Cellulose mainly fungi excreta cellulose enzyme. Oh, हाँ सर जी जी सर नहीं सर क्लास ले रहे हैं अभी उसके बाद देखते हैं सर वो 10 महीने का सर हाँ वो बना हुआ है सर दे देंगे सर जी हाँ हाँ सही रहेगा ओके enzymes fungi excrete cellular enzymes like Trichoderma penicillium, fusarium, and foams. Uh, in the if you see the quantity terms, then bacteria secrete enzymes in lesser quantity, and several type of bacteria like aerobic bacteria, anaerobic bacteria, actinomycetes uh, are there for the uh, uh, carbon cycle or decomposition of organic matter into the soil. So these are the bacteria which are mainly decompose the cellulose portion, like Cellovibrio, Cellulomonas, Thermomonaspora, Cytophaga, कुछ anaerobic bacteria भी हैं that is Acetovibrio, Bacteroids, Clostridium, Rhinococcus, Actinomycetes are Micromonospora, Nocardia, Streptomyces. So these are microorganisms which are responsible for decompositions or used as metabolites for the cellulose. In case of hemicellulose, fungi like Trichoderma, Penicillium, Fusarium, foams, bacteria like Bacillus, Echinobacter, Pseudomonas, Lactobacillus, Vibrio, and Actinomycetes like Streptomyces mainly takes part. In case of a starch, the fungi Aspergillus is the most important one, Fusarium, foams, Lupus. In case of bacteria, Bacillus, Achromobacter, Chromobacterium, Clostridium. In case of Actinomycetes, Micronospoma, Nocardia, Streptomyces. So these are the microorganisms which are mainly participates in the starch metabolizations and their decomposition. The fungi itself indicate mode attack, and most active fungi is white rot fungi. Even the mushrooms are well known for the so oyster mushroom, Cetec mushrooms are the main fungi which are responsible for the decomposition of lignins.
Excuse me, sir.
Okay. Now we move to the another important cycle, that is nitrogen cycle. This is the most important one. Okay. As we know, the nitrogen which is present in the atmosphere are in very much in a high quantity, and most of that nitrogen present in the atmosphere in the inert form. And if you see,
Excuse me, sir.
uh,
Excuse me, sir. Slide is not visible.
okay, so we are going to the nitrogen cycle, in which we have seen that nitrogen is present into the atmosphere, that is in form, and that is unavailable to the plants most of the system. And if you see the abundance of these nitrogen, it is 0.7 tons in per square feet area. And so on 1 square feet, there is a load of 2.7 tons of nitrogen. And these nitrogen are important source for the synthesis of protein into the plants. Okay, so they are important for plants for the protein cultivation. There are different states of these nitrogens. There are oxidational states. There are different fecal states also, and there is a very important role of micronutrients in the conversion. This conversion are identified by the Lonis in 1913. He identified the conversion of nitrogen into the soil micronutrients. They identified the cycle 1930. Hello, is it audible?
Yes, sir.
मेरा चश्मा ले आना फिर। So if I burns and about 400 million tons of nitrogen per year transported in the pools. There are different pools of nitrogen also. We have studied also. We 15 million tons of nitrogen per year lost through the denitrification process, and 185 million tons nitrogen per year lost through the volatilization and combustion process. Okay. There is a loss of 170 million tons of nitrogen per year, and they are fixed into the biological nitrogen fixation, and they are fixed into the terrestrial regions through the in the plants or in the algae, in the oceans, in the hills, in the forest, everywhere. And approximately it is estimated that about 170 million tons of nitrogen per year is biological nitrogen fixation. Industrial fixation is about 60 million tons nitrogen per year. Industrial nitrogen fixation is there. If you see the nitrogen cycle, in the center also, center of the cycle, there is a plant system is there, and through the plants, that is the food for the animals, and there may be decompositions, and that may be incorporated into the field, and they will be converted into the compost or organic manures, and Several microbes are also active on these. So through the process, different processes of ammonifications and assimilations, ammonia is either released or it is assimilated by the plant system. Okay. So A is for the mineralization process and B for the ammonification process. So through the mineralization, in which microbes are mainly responsible, and they decompose the organic matters, and after decompositions mineralization takes place and ammonia is released. There is also uh, ammonification process is there is a nitrification process through which ammonia is converted into nitrate, and denitrification process is also there. So which nitrate is that is oxidized form nitrogen is converted into the elemental nitrogen, and in gaseous form they are escaped into the atmosphere. And this F, that is nitrogen biological this indicate the biological nitrogen fixation in which atmospheric nitrogen is made available to plants for the biological nitrogen fixation system. Then G is also there. G, through which the uh, nitrate reduction it takes place, and through the nitrate reduction they are again converted into the ammonia. And H is also there. H, to the H process, that is immobilization is there. Ammonia is taken up, as that is the microbial assimilation process, which the microbes are taken up the ammonia into the soil. These ammonia and nitrates are taken up by the plants for the growth and development of the plants, and after decompositions, which is associated with the microbial actions, they are converted into the humus, into the biomass, into the soil system. Now, we have discussed all these things in the first semester also, that is the ammonification process, in which ammonia is uh, synthesized, or it is converted into ammonia through the process of ammonification process from the protein and amino acid. So plant or animal protein which are present in organic matter that undergo decomposition by the various microbes present in the soil system, and the enzyme protease break peptides to amino acids also. So protease enzyme consists of two components, that is exopeptidase that act on simple peptides, then endopeptidase that hydrolyze peptide bond of protein chain from the terminal ends. So these also called proteinase because it can hydrolyze both protein and peptides. So the process of conversion of amino acids or protein or organic form of nutrients to ammonia. Okay, so in this group, the proteins which have amino acids and that after the enzymatic hydrolysis, they are converted into the ammonia, and ammonia further hydrolyzed with water, and ultimately they are responsible for the ammonification process. So the mainly the nitrogenous compounds mainly used for the decompositions, and after decomposition they are converted into ammonia, that is proteins, amino acids, amino sugars, nucleoproteins, amides, purines, nucleic acids, pyrimidines, alkaloids, chitins. So all these are nitrogenous compounds, and these nitrogenous compounds are decomposed and acted by the microbes. They are converted into the ammonia by the ammonification process. Mainly heterotrophs microbes are actively participate in this process. There is also deamination process. In this process, amines are detached from the amino acids, and release of ammonia from amino acids occur through a process known as deaminations. So it may be oxidative or reductive, or sometimes decarboxylative process. So several processes are there. So this is the oxidative deamination process. So oxidation takes place and the ammonia will be released. Then reductive deamination process is also there. So reduction it takes place, and through the reduction process ammonia it comes out. Another one is the decarboxylative deaminations, The, decarboxylation it takes place, and through this process, ammonia is also comes into the system. So these are three processes by which the ammonification takes place. First one is the oxidative deamination process, in which oxidation of the organic materials or nitrogen compounds takes place. Another one is the reductive deaminations, in which reductions takes place of the protein molecules or amines. Another one is the decarboxylative deamination process. Then nitrification. So after ammonification, the further oxidation of ammonia will be takes place, and this process is known as nitrification, and it is the process of conversion of ammonia into nitrate with the intermediate product of nitrite, and that takes place in the presence of microbes, that is the nitrosomonas and nitrobacter. So these are mainly the autotrophic bacteria which takes part in the ammonification. Heterotrophic bacteria when participates, but in nitrification, autotrophs are mainly associated with the process. So this is two-stage process in which the intermediate product nitrite is formed, and nitrosomonas and nitrobacter microbes, bacteria mainly responsible for these two-stage conversion. So in this conversion, nitrite to nitrate conversion is so fast that nitrite accumulation is rarely beat. If nitrite accumulation takes place, then the surrounding environment will be not suitable for the microbial benefits. So we have to make such conditions in which nitrite does not accumulate. Okay, so nitrite to nitrate conversion is so fast that nitrite accumulation is rarely meet within soil. For this purpose, for fast nitrification, certain factors are there which are responsible. That is aeration, moisture, temperature, pH, and organic matter. That is the most important factors which control the nitrification process. Aeration is required. Proper aerations or at water holding capacity, they mainly accelerate the nitrification process. So under waterlogged condition, oxidation of ammonia prevented and may be lost by volatilizations, and in that case, nitrification is affected. Another one is the organism may become inactive below pH 5.5 and may be reactivated by the liming process. Okay, so the process is rapid during summer and it is slow in the winter. Okay, the activity this is due to the activity of microbes which enhance in the summer due to the temperature, whereas slow in the winter with the low temperature. Then nitrification inhibitors. I have told you that is one NSERP. First one is the NSERP, that is the 2-chloro-6 trichloromethylpyridine, that is nitrification inhibitor that inhibit the nitrification process. So another one is the AIM, that is 2-amino-4-chloro-6-methylpyridine. So these two are the nitrification inhibitors which inhibit the process of nitrification. So these two chemicals compounds, the inhibitors, that is NSERV and AM, they are also found. These type of chemicals are also found in Pongamia glabra and Azadirachta indica, and have similar property for the nitrification inhibitor. So these Pongamia glabra and Azadirachta indica, their cakes, oil cakes, can be used for the nitrification inhibitor, or if they are added to in the fields where the nitrification process is fast, in that case their application reduce the nitrification process. Now ammonia released through the ammonification is either there is several fates of the ammonia, so they may be taken up by the plants, or they may be taken up by the microorganisms, or go through the nitrification process. Okay, so there are three fates of the ammonia which are released during the ammonification process. They are taken up by plants, they are taken up by the microorganisms, or they may go to the nitrification process and yield nitrate. Okay, so under aerobic conditions, some chemoautotrophs drive energy from the oxidation of ammonia, and in that case, the uh, inorganic nitrogen which are mineralized, that is the that is equal to the nitrogen mineralized, total nitrogen mineralized minus nitrogen assimilation by the plants, nitrogen assimilation by the microbes also, and nitrogen that is the taken up by the plant systems, and the denitrification process. Okay, so that is the equation that is created. So this is the when we break the nitrification equation, then it is the two-stage process. In first stage, ammonia is converted into nitrite, in which energy is released. 275 kilojoules energy is released, and microorganisms, that is the bacteria, Nitrosomonas, Nitrosococcus, Nitrosospira, Nitrosolobus, are mainly responsible for the conversion. In case of nitrite to nitrate, 76 kilojoule energy released, and nitrobacter and nitrospira microorganisms, bacteria mainly uh, used for the mainly responsible for the conversion. Another one is the nitrous or nitric acid formed during the nitrification that react with the calcium carbonate to form calcium nitrate or calcium nitride in soil. Even potassium nitrate is also formed. So the process is high in autumn and spring, and low in winter and summer. Okay. These are the conversion of ammonia to nitrite proceeds step by with the formation of some intermediate compounds. So several intermediate compounds are also formed. So in the first case, when ammonia hydrolyzed, they are oxidized, and hydroxylamine is formed in the presence of ammonia monooxygenase. Then these hydroxylamine is again oxidized, and in the presence of oxidoreductase, and hyponitrous acid is formed. And this hyponitrous acid is again oxidized with the terminal oxidase enzymes, and they are converted into the nitrous acids. And these nitrous acids finally, with the presence of nitrite dehydrogenase, it is converted into the nitrate, nitric acid. Okay. So there are some intermediate compounds are also formed, and there is a chances of loss of nitrate also. And in this case, the intermediate in autotrophic nitrification showing the possible sites for gaseous losses during the process. So there is a gaseous loss of NO, and N2O takes place in the as a intermediate compounds. In case of heterotrophs, the losses are minimized. There is no losses of nitrogen in the NO form or NO2 forms, and so there will be uh, uh, more efficiency there. So the bacteria, that is arthrotrophs, cloviriformis, aerobacters, aerogenus, Mycobacterium feli, Streptomyces, Gracis, Thiospira, Pseudomonas species, all these are mainly responsible for the heterotrophic nitrification. आज इतना ही रहने देते हैं, हम लोग को भी दूसरे जगह जाना है, एक मीटिंग है ना। वेडनेसडे को मिलते हैं, ठीक है। कोई भी क्वेरी होगा तो वेडनेसडे को बात करेंगे।